U.S. Army Aviation Test Activity, a tenant at Edwards Air Force Base, performs flight tests for engineering evaluation of aircraft and associated equipment. The widely varying terrain and topography especially suited to testing Army aircraft can be found within relatively short distances of this desert base. Then, too, the extensive Air Force facilities here are available for testing Army items. An element of the Test and Evaluation Command of the Army Materiel Command, the aviation test activity typically begins a project with the detailed planning necessary to assure that items under test meet appropriate specifications and that flight characteristics are suitable for service use. Also, matters of primary concern are determining safe operating procedures and practical limits of equipment performance. In conferences like this one, decisions are made affecting such key factors as test requirements, personnel, instrumentation, and logistics. Here, a project engineer and project test pilot are about to begin testing an Army troop and cargo carrying aircraft, the Caribou. This plane was designed for short takeoffs and landings on various types of unimproved terrain under combat conditions. Tests of the Caribou, shown in this film, are representative of those conducted by the test activity on a variety of aircraft. All tests, regardless of the type of aircraft concerned, are classed as either performance or stability and control. Here, the pilot checks the swivel boom, a sensitive airspeed indicator. Inside, an oscillograph is being installed. This oscillograph will record such data as stick and control positions, acceleration, roll, pitch, and yaw rates, and other functions, typically ranging from 8 to 16 in number. As the pilot makes his routine pre-flight check, the project engineer takes a fuel sample. The sample is used to determine the fuel's specific gravity at the prevailing temperature. This information is needed to determine the actual weight of the fuel in calculating fuel consumption. As the Caribou taxis out for takeoff, a Fairchild flight analyzer is prepared to photograph its changing position as it climbs over a predetermined point in space at an elevation of 50 feet. The resulting photographs will provide both time and distance scales. From this and other sources, the baseline data were gathered at Edwards' elevation of 2,300 feet for later use at altitudes ranging from sea level to 9,500 feet. During both takeoff and landing, a visual theodolite is used. This device enables the test team to evaluate the progress of a test as the test is being carried out. Here, the takeoff is from a soft sand area near Yuma, Arizona. Takeoff and landing tests were also conducted on soft clay and concrete surfaces. Performance data are continually recorded during flight. By an orderly process of planned trial and error, the best landing and takeoff procedures were determined. Here, the pilot receives instructions from the project officer on the desired approach, including such factors as airspeed, aircraft configuration, power requirements, and technique. This kind of result indicated the need for better wheel bearing seals as well as larger tires. The higher altitude tests began at El Dorado County Airport, elevation 7,000 feet. What effect would this elevation, 4,700 feet higher than Edwards Air Force Base, have on landing and takeoff performance? How much distance would be required in both cases? How would the effects of reverse propellers compare with those experienced at lower altitudes? To help answer such questions, the project engineer records airspeed, fuel flow, atmospheric pressure, engine RPMs, and temperature. Horsepower output of the engines is computed throughout each test run. At El Dorado County Airport, the test team enjoyed the almost ideal windless weather required for aircraft testing. At Bishop, California, in Owens Valley of the High Sierras, the test activity makes use of still another test site, this one at an elevation of 4,000 feet. A principal advantage of this location is its low-density air traffic. It is also near other high-altitude test sites ranging up to 13,500 feet above sea level. Near Seattle, Washington, landings were made on wet grass, a condition to be found in much of the world, including Southeast Asia. A key objective was to determine the effect of propeller reversal on stopping distance. Maintenance was performed at the test site. Besides skilled mechanics, the test teams require 15 other kinds of specialists. The CH-46 helicopter flies in personnel and supplies in support of the test. The smoke produced by burning old tires aids the pilot in determining wind conditions during tests. This particular test site is called Coyote Flats, located 9,500 feet up in the Sierras. This elevation, 2,500 feet higher than El Dorado County Airport, makes possible the collection of data for a still wider comparison of takeoff and landing performance at varying altitudes. On this unimproved hard surface, the Caribou performed very well. As during all tests of the series, both the Theodolite and Fairchild analyzer were manned. Based on results of such takeoff and landing tests, the aviation test activity defines optimum techniques and configurations for maximum performance during service use under all conditions. Airborne instrumentation, the sensitive gauges for determining power, speed, and atmospheric conditions, which require hundreds of man-hours to install and check out, proved their worth by providing data for an accurate determination of the aircraft's mission capability. Engineering tests of aircraft other than fixed wing are also a responsibility of the Army Aviation Test activity. Here, an oscillograph is installed in an H-23 helicopter. The camera will record such data as pitch, yaw, and roll rates, control positions, and acceleration rates. Helicopter tests are quite similar to those for fixed-wing aircraft, being classed as either performance or stability and control. Tests are designed to determine performance and handling characteristics of the aircraft to form recommendations for field use. Tests on the H-23, an off-the-shelf item, were conducted to obtain comparison data for tests conducted on the Light Observation Helicopter, or LOH for short. Here, an Army CH-46 cargo helicopter is about to undergo a hovering test. For this test, the aircraft is tethered to a weight buried in the ground called a dead man. Between the helicopter and the dead man, a load cell measures the lifting power of the aircraft in pounds. This method of measuring hovering performance was developed by activity personnel. Here, lead weights are placed aboard a UH-1D to test performance while carrying loads with varying centers of gravity. Ballast is added about every 5 minutes to offset the effects on the center of gravity of weight loss due to fuel consumption. Various lengths of tether cable are used to determine performance at different hovering heights. Valid testing of helicopters, as with fixed-wing aircraft, requires almost windless weather. At the plant of an Indianapolis contractor, Army Aviation Test Activity personnel participate in testing a new engine designed for the Army's new light observation helicopter. The test platform is an XUH-13R. Activity personnel serve not only in the various states as here, but all over the globe. Modifications to Army aircraft affecting flight characteristics are normally evaluated by the Aviation Test Activity. The activity recommends to the Test and Evaluation Command adoption or rejection of modification. Here, a technician processes an oscillograph record. This is done as soon as possible after each test to determine whether the test was successful and that necessary data were obtained. Test activity engineers examine all data records, usually on the night of the day the test was performed. Thus, when necessary, tests can be repeated promptly and time schedules more readily met. More refined reduction of test data is performed by the activity's modern computing equipment. Here, the various forms of raw data are converted into meaningful numbers. The reduced data are sent on to the engineers for analysis and preparation of the final test report. Here is the engineering evaluation of the test item, its weaknesses and strengths under varying conditions, the information essential for preparation of operation manuals. You have seen the highlights of a few typical tests conducted by the Aviation Test Activity. In the past, a number of Army aircraft have been successfully tested by this organization, and activity personnel look forward to future tests, including several tri-service programs. But whatever tomorrow's specific tasks, the overall goal of the U.S. Army Aviation Test Activity will continue to be the acquisition of as complete and unbiased test data as is humanly possible.